Hey guys, 6.5, graphs of polar equations. So please ignore Mr. Hazelwood. We're just, as always, right? As always, testing for symmetry.
As always.
Yes.
Right.
A lot of these polar equation-y graphs, like the graphs that in particular we're interested in having
The ones that we're going to
equations,
study. The ones that we're going to
interesting
study.
ones.
Yeah, the fun ones.
Yeah, there's a way to test for symmetry, which is this right here, that about the x-axis, you take the r's and the thetas and you replace them with like
Those r's and thetas.
Those r's and thetas, right.
Yeah.
And so it's kind of a tricky situation where, I mean, it'd be really hard to do without graphing it or having this there with you.
Yeah, that's
right?
correct. And it's really similar to trying to determine if a function's odd or even.
It is.
There's a lot of similarities
between
those things. And
because
that
that's
was kind of
related
hard.
to symmetry.
So, right.
So we're going to use the symmetry test to show the graph is symmetric about the y-axis. Well, that's helpful. They told us that it's this one right here. It's about the y-axis. So we would just have to say, okay, I have r and theta here. I'm going to replace it with one or the other of these. Always pick the easier one.
Yeah, for sure pick the, which means no pi minus business.
Right.
Usually.
So we're going to put a negative r where r is and a negative theta where theta is, and we're going to see if we end up with this, what we started with.
Right. And well, yeah.
Yeah?
Yeah.
Okay.
Yeah, I totally agree with everything you just said.
Okay.
So go ahead and do some swappage. Now, you'll need your trig cards, or you'll need to try and remember a trig identity, because that's where a lot of this work is going to happen.
Right, because basically what we need to know is this negative, is that going to go away, or is it going to be put in front?
I don't know. That's the question.
Well, if you look at your circle card at the odd and even identities, a negative inside the angle of sign.
I know. It goes into the front.
It goes into the front.
Now, the 3 has to stay inside the sign.
It doesn't. Only a negative.
Just the negative comes out.
Possibly come out.
Right.
So, all right. So we end up with this. Now, what can we do?
I have a great idea.
Yeah.
Divide by -1.
Okay, on both sides.
No, take that back. Multiply both sides by -1.
That's the same thing.
No,
so can I just
division
leave
and
it?
multiplication are not the same.
It is whenever we're talking about -1.
Well, speak for yourself.
Okay. Speaking for myself, I divided by -1.
Hey, we got back to where we started.
We got back to where we started. Proof done.
Yeah.
We did, in fact, prove it. And if you look at the graph of this, we got some really interesting curves in this section. One of my
kind
favorites,
of enjoy this section, honestly.
These are called rose curves because they look kind of like flowers because you've got like petals here. It's kind of neat. And this one doesn't, it kind of looks like, I don't know what kind of flower that is.
Looks like an airplane propeller.
Yes. There's a flower that looks like an airplane propeller, and that's the flower I was talking about.
Oh, I don't know what they're called.
I don't know what they're
I know
called.
what a lily looks like, and that's about all.
Okay.
Maybe a rose.
But, okay. So, if you look, it has symmetry along the y-axis because we can fold it.
In half, smash it, and it's going to be the same mirror image on each side.
Right.